Bismillahirrahmanirrahim. Good morning, everyone. Today we will have the last part of lesson 3, the thermal energy and heat. In the last lesson, or in the last period, we talk about the difference between the thermal energy and the heat. We said that the thermal energy is the total amount of kinetic energy in an object. And all the particles kinetic energy, the total amount of the particles kinetic energy. While the heat is the transfer of the thermal energy. It's only the transfer of the thermal energy. Okay, now and we said that always the heat transfers from warmer to cooler objects, and I told you that this is a law. Only the thermal energy can transfer from hotter or warmer to cooler objects, not the opposite at all. Today we will talk about the 3 ways in which the thermal energy can be transferred. Let's see. The energy can be transferred by 3 ways: conduction, convection, and radiation. Actually, I preferred to summarize this part of lesson the same way that we used to do in our class, especially that some of you asked me to do that, and I'm very, very happy because that happens. That means this way is very, very effective, and it is actually. Here, as you see, the thermal energy can be transferred by conduction, convection, or radiation. Please, we have to memorize them by heart. First, conduction depends on direct contact. Here also I wrote only the keywords for each way. Then we will talk about them particularly. Conduction depends on direct contact. There should be touching between objects, or the particles of the objects should be in touch or direct contact. And it takes place in solids, mostly in solids. It can take place in liquid, but mostly in solids. Convection depends on the difference in densities. The difference in densities between the particles. It can take place in the same object. It can take place in fluids. What is the meaning of fluids? Fluids means substance that can flow. It means fluid means gas or liquid. A gas or liquid, both are called fluids. So it can take place in solids. It can take place in solids. Finally, radiation. Radiation doesn't need solid or fluid. It doesn't need matter at all. It can take place without matter. Why? Because it depends on the waves, on the electromagnetic waves. And from the last lesson, from lesson 1 in this chapter, we said waves don't need, the electromagnetic waves don't need matter. They move without matter. Okay? And in this way, the sun sends its thermal energy to us. The first way is the conduction. We said the conduction needs direct contact between the particles of one object or 2 objects. Second, it takes place mostly in solids. Okay, it can take place in one object, in the same object, within the same object's particles. How? From the warmer part to the cooler part of the object, or between 2 objects, from the warmer object to the cooler object. Let's see an example about how the conduction takes place in one object.
So here I have a metallic spoon, and I imagine holding a match underneath it. Now what we know is that that spoon is going to heat up.
Sorry for
By
this
thinking about
delay.
an example. So here I have a metallic spoon, and I imagine holding a match underneath it. Now what we know is that that spoon is going to heat up, and not just the part of the spoon that's over the match, but rather the spoon as a whole. And the reason this happens is because of conduction. Energy from the flame is causing the molecules within the spoon to vibrate, and that's transferring energy from one to the next, to the next, to the next, until the entire spoon has warmed up. That heat has...
So here he explained for us that when the flame heats the left part of the spoon, what will happen in the particles? The particles will have greater thermal energy. They will move faster and faster, and they will every particle will hit the particle that is beside it. So the thermal energy will move from a particle to the next, to the next, to the next, until all the spoon will have the same thermal energy. Until for sure the flame keeps heating the particles to the left, so the thermal energy will increase and increase and increase, and when it increases in one particle, it will increase in the next particle, in the next particle, until all the spoon becomes with the same temperature. Okay, so we can memorize only this fact, that the thermal energy will transfer from warmer part to cooler part until all the object becomes in the same temperature, exactly like what I wrote for you in our summary.
Conduction is a process in which the transfer of heat takes place between objects by direct contact. It is most often associated with solids. The key to conduction is direct contact. The heat of the pan is transferred to the mini pizzas. The energy of the frying pan is transferred to the eggs. Notice that they are in direct contact. Convection is heat transfer by the movement of a fluid such as air or water.
As we have seen in the last example, the thermal energy moved or transferred from the pan to the pancake by direct contact from one object to another, from the warmer to the cooler. And that's what happens if you put your hand also on a warmer object. What will happen? Directly the thermal energy will transfer from the warmer object to your hand. If you shake hand with someone who comes from outside, if it was hot, directly you feel that your hands are cooler, his hands are warmer, so your hands directly will become warmer. That's it. This is the conduction. And here what explain how conduction takes place? The molecules movement. The molecules, when they gain more thermal energy, they will move faster and faster, so they will hit each other. They will hit the other particles that move slower, so the thermal energy will move from a particle to another, from a particle to another, until all the object or the two objects become with the same thermal energy, and in the result with the same temperature. Here are some examples about the direct contact or about the conduction. Here, this picture here, it shows the three ways of transfer of energy. The radiation down from the flame to the object, and it can be also by convection and direct contact when this man holds this man here, this hand holds the stick, as you see, by conduction. So here, if you touch the iron or when you iron clothes, this is conduction. This pan on the fire, if you touch also the pan, this is conduction. Here, this turtle on a hot rock will get the thermal energy by conduction. This girl here, she puts her hand on the stove or on the pan, so the conduction takes place. Depending on conduction, we can say that all materials can be good conductors or insulators. What's the meaning of a conductor or insulator? Conductor, it means conducts the thermal energy very well. A material that can conduct thermal energy very well. Such as what? We studied that in the last chapter when we talk about the physical properties of metals, if you remember. Metals are good conductors, right? Because electrons can move freely. This is also, electrons can move freely. This means they are good conductors for electricity. Here also, they are good conductors for thermal energy, because their molecules their atoms can move quickly, and this will move the thermal energy from an atom to the next, so they can move the thermal energy, they can transfer the thermal energy very well. That's why it's better for you to use, when you cook, when you stir something on boiling pot, or when you are cooking, it's better for you to use a wooden spoon, not a metal spoon. Why? Because the metal conducts the thermal energy very well. It's good conductor. So the metal spoon will become hot very, very quickly, and this will burn your hand. Why? While if you use a wooden spoon, this will protect your hand from being burned. Okay? Insulators, the opposite, materials that are poor conductors, or they don't conduct the thermal energy very well, such as wood, paper, plastic, foam, and other materials. Now we will talk about the convection. What is the convection? Actually, the convection is the transfer of energy as heat by the movement of a liquid or gas. As I told you, fluids. How that will happen? I want to depend on let's see here first these examples, then we will go to our summary. Look at this boiling water in this kettle, how the water is moving circularly, in circular motion. You see, the circular motion here of the water is the convection. Also, the air, if there was fire, the air above the fire will move in the same way, in circular motion. Let's see. As you see here, the convection occurs only in fluids. It doesn't occur at all in solids. It depends on the density, on the difference in the density, in the densities of the particles. Let's see how. Look at this. This is a cup of water. It's on the fire. For sure the fire will heat the cup. So what will happen to the particles? The particles directly will start having greater thermal energy. Okay, by direct contact. First here it happens by direct contact between the flame and the container, then between the container and the particles. Now what will happen? Now here we will start now in the convection. The particles down will have greater thermal energy. That means they will move faster. When they move faster, they will get farther from each other. That's what we learned, right? Okay, when they get farther from each other, that means they will have greater spaces with the same mass for sure. That means less density. Remember, what is density, girls? What is density? It's the relation between the mass and the volume. Okay, it is the amount of matter for a specific volume of matter. Okay, so when they get farther, they will become with less density. If they become with less density, what does that mean? Remember, to sink or float. They will float or sink. For sure they float. That means they rise up. They will rise up. They become less in density. That means they become, they can rise up. That means they are less in density than the particles that are up. What will happen to the particles that become up, that are up? They will sink down because of the difference in densities. Always denser sinks, less in density goes up, rise up. We will not say here float because float needs another object. We will say we rise up. Okay? The denser or greater in density sink, while the less in density, the particles that have less in density will rise up. That's it. So we will have circular motion until all the particles become with the same temperature, and that's how all the water will start boiling. All of us, we know, if we start boiling very, very big pot of water, first put your finger up in the water, you feel the water is cool. Even if you are heating the water up, it is cool. Then after few seconds, within seconds or minutes, depending on the volume of the water, you start feeling that the water up becomes warmer. How that happens? It happens by convection. It happens by convection. The warmer particles will rise up, cooler particles sink down. The cooler particles, here when they sink down, they will become warmer. They will rise up again. The upper particles, when they go up, they will become cooler. They will rise down. The particles down become warmer. They will rise up, and again until all the water become with the same temperature, until all the water become warmer. Okay, this is about convection, and it can take place in the air. We can see that here. Look at this. The example that I talk about. As you see, what will happen to the particles? They become warmer. When they become warmer, they become with less density, they rise up. So what will happen to the cooler particles? They sink down because they are denser. When they sink down, they will get warmer from the source of energy. So they will rise up. That's it. This what happened also in the air. Exactly the same. Finally, we'll talk about the radiation that needs no direct contact, no contact at all, doesn't need any contact between objects or between particles. No matter is needed, so it can take place in the space without any matter. It can occur with the exist of the matter, but it doesn't need the matter. Okay, يعني some stoves, or if we put our hand beside the fire, we will get warmer because of the radiation, because of the movement of the waves. With the exist of the air, yes, there is air, there is matter, but the waves don't need the air. They move without the air. So these are the main points. No direct contact, no matter is needed. The energy is transferred by the electromagnetic waves, such as the waves that come from the sun. Okay? The thermal energy transfers from the sun to us by radiation. Let's see how that takes place. Wait. Look at this. The sun sends its thermal energy to us by radiation, and it doesn't need matter. If it needs matter, the sun can't send us any thermal energy, because as you know, the space doesn't have matter. This is everything for today about the ways in which the energy transfers. I hope that was enough. Please summarize for yourself, study very well. Inshallah, tomorrow our periods for this week are done, finished. We have 4 periods for week and we are finished, alhamdulillah. But inshallah, tomorrow I will send you only a worksheet to solve it during the weekend. Okay, it will not be a difficult one. Enjoy your weekend. I hope that I made it easier for you by summarizing, by this PowerPoint, by my explanation. If you have any question, send it to me. Assalamu alaikum.